Hi, in this video, I'll talk about installment payment plans. I'll go through what it is, shows a little bit of the math, and show how these problems can be solved using a spreadsheet program such as Microsoft Excel or Google Sheets. There are two kinds of installment payment plans, and they work the exact same way. They just go opposite directions. One is if you start out with a loan, so you have a big loan like this, and you start paying it down slowly, so eventually it gets down to zero. That's one form of installment payment plan. The other form of an installment payment plan is that you start with nothing and you start to save money into some sort of an investment account or savings plan. So you keep paying in and interest grows at the same time, and eventually you have some large amount of money. In general, the starting amount that you have, either a small amount that you invest at the beginning or zero at the beginning, or a large amount of loan at the beginning, that's called the principal or the present value. The payments that you made are called payments, obviously, and the ending balance is called by various names: ending balance, accumulated amount. For purposes of the spreadsheet, is called a future value. Let me repeat that with a diagram. You could have a situation with a loan where you start out with some amount that you borrow, and then a loan comes with an interest. So the starting amount is called the principal or present value. The loan comes with an interest rate, and the interest is compounded, so it grows exponentially. The interest rate is usually written with the lowercase r. Well, left alone, the loan will just grow exponentially into a very large number. So what usually happens is that you make a payment. You make a payment that's larger than the interest, so that first of all, it pays off all the accumulated interest, and it pays a little bit of the principal, so that with each payment, the loan balance goes down by a little bit, and you're hoping that eventually you'll go down to zero. Each month, usually, you make a payment. Well, and then after that, interest grows again, and then you make a payment again, and then interest grows, and you make a payment, and interest grows, and you make a payment. And eventually, the balance becomes zero. The balance in the future, either you're asking yourself what happens after 5 payments, or at the very end, either of them is called a future value. So each of these is a payment, usually abbreviated PMT. And then the value in the future is called the future value, of course. The length of time it takes to complete the loan is called the term of the loan. Now, for a typical loan, the interest rate is given at a number that is per year. The term is typically in years, but the payments are typically in months. So one of the things that you need to do in a math problem is to change all of this to months, to the same unit as whatever the payments are made. If you have a different kind of problem where payments are made per week or per quarter, then change everything to that. So basically change it to whatever period is covered by each payment. That's a situation where you have a loan. Now the opposite situation, but equivalent, is when you put money into some sort of savings plan, some sort of investment account, and watch it grow. You put the money in, it grows by a little bit, you add some more payment, etc. So you start out with nothing and you make a payment. Because of this payment, you get some interest growing, and next month you make the same payment again. Great. Let's watch it grow. And same payment, watch it grow, same payment. Again, you have a future value of some sort. So at some point you have a lot of money because you've been saving. So that's the future value. The length of time here, usually when you invest, you don't have a fixed term. You just keep investing until you're happy with the money you have. So there isn't like a fixed term. But for purposes calculation, we would like to count how many times we've been making these payments. It's a number of payments. And since each payment is made per period, such as month, we generally call it the number of periods. And in both Google Sheets and Excel, it's abbreviated NPER. Now, in terms of counting time, because sometimes instead of saying, oh, how much money will we have after 120 payments, it's usually asked as how much money will there be after 10 years of making monthly payments. So we also count as time. But the tricky part is this. Remember the loan, we start out with a big loan and then we let it grow and we make our first payment, right? Our first payment is 1 month after we get started. That's usually how loans work. For savings plan, when we talk to each other in real life and we say things like, I started an investment plan yesterday, that means I made my first payment yesterday. So in reality, the time period should start when I first make payments. But just to make the situation equivalent to the loan situation, in math, we pretend that we started back here with nothing. So it's not like we change reality at all, no, but we just pretend that in terms of counting how many years, we just started like 1 month early. In math, we always pretend that the payments are made at the end of the first month. That just makes the math easy. You can tell that all of these things, the future value, the present value, the payment amount, the number of periods or number of payments, and the interest rates, they all relate to each other. You change one of them, the rest of them change. Okay, you change the amount of payments you make per month, you're changing the future value of your investment. You make the same payments, but you have a better interest rate, you have more money at the end. Or you have a good interest rate, maybe you don't need to make that big of a payment in order to get the same future value. So these things are all related. And it's the same thing with the loan. All of that come together in one big math formula that gets translated into the spreadsheets like Google Sheets and Excel. Now let's talk about the math. If I use PV as the principal or present value, PMT is the payment amount, little r is the annual rate, little n is number of payments per year, and little t is the number of years, so that the NPER, the number of periods that we talked about earlier, is not just n, but nt. Then we have this formula. The payment is equal to the present value times big formula where this blank here is the interest rate per period. Well, the interest rate per year is R, and there are n period per year, so it's R over n. Now, you can solve for present value out of this. So for example, if you know someone's how much they pay per month and you want to know how much the loan was, you can solve for PV out of this. And you end up with PV is equal to, the original formula has PMT is equal to PV times that big expression. But at the end of the day, that big expression is a fraction. Okay, so if you want to compute PV, you flip that fraction over here and basically divide it. So I'm flipping that fraction over and I have all of this here. 1 minus this massive math. It was in the denominator, now it flips to the numerator, and then the R over N used to be in the numerator, now it got flipped to the denominator. That's a situation with a loan where you start with an amount and you want to end up with 0. An investment plan, you start with a 0 and you want to end up with a vast amount in the future. So for an investment plan or savings plan, what you're computing is the opposite of the loan, right? Instead of start out large and end up 0, you start out 0, you end up large. This same formula here, if you look at it from the opposite direction, instead of from present to the future, you look at it from the future back to the present, then you're getting the savings plan formula. Therefore, this whole formula becomes a formula for the future value of the savings plan. Okay, the savings plan is opposite of a loan. The loan starts large and goes down to 0. The savings plan starts at 0 and goes back large. So everything goes opposite. the present becomes a future becomes a present. Everything else is almost the same, except because instead of paying down a loan, you build up a savings plan. It just switches sign from positive to negative, negative to positive. And therefore, this subtraction here will go opposite. Like that, and the whole thing divided by R over N. All of these formulas, they start out with just one formula for the payment amount. You solve the present value of the loan from it, you get the second formula. And then you realize that because the savings plan is the opposite of a loan, you just switch everything present to future, future to present. And instead of subtracting things one way, you subtract it the opposite way. So all these three formulas are related. All right, now, I'm not going through any of these formulas, but I am going to show you how to solve these kinds of problems by using Google Sheets and Excel. Let's take this example. Phương borrows $250,000 to buy a house. The loan on a house is called a mortgage, has a term of 30 years, an interest rate of 4% a year. How much is the monthly payment? All right, so let's draw a diagram first before we pull up Excel and Google Sheets. She borrows some money. There's a huge amount of loan at the beginning like this. That's called the present value or principal. It grows with interest, but after the first month, Phương makes the first payment and it drops the loan value down by a little bit, and then interest grows again and she makes another payment, grows payment, and eventually she pays it off. She paid it off in 30 years. So the term is 30 years. Don't forget it's about years, but the payment is monthly and the interest rate is 0.04 a year. Future value is 0. We have a mismatch in units. The payments are per month. The term is in years, and the interest rate is also in terms of year. So we need to switch everything to month. Well, 30 years, that means it's 30 times 12 or 360 months. What about the interest rate? It's 0.04 a year. There are 12 months in a year, so each month is 1/12 of that. So to get the interest rate per month, I just divide by 12, and then I'll get the interest per month. All right, now let me show you how this is done on a spreadsheet. Let's do it in Excel. First, I'm going to put in the information, present value or principal. is 250,000. Remember, when typing numbers into Excel, don't put in commas, because the comma has special meaning in a formula. Don't type the comma. 250. The next piece of information is that the term is 30 years. So T is equal to 30 years. Number of periods, therefore, is equal to 30 times 12. When you want Excel or Google Sheets to calculate things, start typing with an equal sign. And the interest rate, R, is 4% a year. So that's 0.04 in decimal form. And now I'm looking for monthly payments. Monthly payments. So I'm going to start with an equal sign, and I'm going to type in PMT for payment, PMT, and see how automatically Excel comes up with all the functions that has PMT in them. And I'm going to pick the one that just says PMT. I click on it, and it gives me a reminder of what kind of numbers to put in. It tells me first to put in the rate. So yep, this rate. But that rate is the annual rate, so I need to divide by 12. So divide by 12. Then comma, NP, or number of periods, is this number. So I click on that, comma. The next number that we need to enter is PV. PV is 250,000 right here. And then the next two values that we are supposed to put in are FV and type. FV for future value, and it has a bracket around it. That means it's optional. You don't have to type it in if you take the default value. And the default value for these formulas is that future value is going to be 0. So I go comma 0 for future value. And the type is, I put in 0 for the end of the period, payments made at the end of period, or number 1 at beginning of period. And in a math class, we always assume that payments are made at the end of the period. Like I said before, if it's not made at end period, let's pretend that we got started last month, so it becomes end of period anyway. These two values are 0, 0, and I really didn't need to put them in because they're the default value. I'm putting them anyway to illustrate. And hit enter, and the answer is negative 1193.54. Negative 1,193.54. In Excel and Google Sheets, payments amount are considered negative because you're paying out. When you're paying out, it counts as a negative. Let me do the whole calculation again without the two default values. Equals PMT. First information is rate, which is this number divided by 12. Second information is number period, which is this number, comma. Present value is this number. And then the last two values, because I'm using a default value, I'm just going to close out the parentheses without typing them. You remember the bracket in the Excel information means optional. So close paren and hit enter, and yep, I get the same answer, $1,193.54. As a negative number because it's money we pay out. In Excel, negative is written, first of all, in red, and second of all, with parentheses. That's traditional for financial calculations. Now let me pull up Google Sheets and do the same thing all over again. First, I put in the information and then I calculate separately. The principal or present value is 250,000. Just like Excel, don't type in the comma. The term T is equal to 30 years. So my number period is actually equals to this number, equals this number times 12. And the rate R is equal to 4%, 0.04. I could also enter separately the monthly rate, but I'm just going to leave it like this, annual. Google Sheets works the same way as Excel. So equals PMT, and it gives me this function down here. So I click on it. First piece of information is the rate. So the rate is this number divided by 12, comma. Let me scroll this up a little bit so that we can see the typing. Number period is this, then comma, present value. This informational box is blocking what I'm typing, so watch the formula bar up here. I'm gonna click on present value, so I'm gonna click on PV here, comma, and check this out. These two pieces of information also in bracket, meaning also optional, works exactly like Excel, assumed to be 0 for the future value because we're assuming that we'll try to pay down the loan. And the end or beginning, either at the end or beginning of the period, and the default is 0 for end. So I'm going to go 0, 0, close brand. Hit enter again, I get exact same answer that I got in Excel, and also as a negative number, also because payments are things that we pay out, so it counts as negative. Again, let me do the PMT again, but without the optional value. So first number is the rate, so this divide by 12, comma, I need the number period, which is this number right here, comma, the present value, the 250 up here, and a close brand like this, enter. Yep, same answer. Now, you see that I've been clicking on the cells where the numbers are listed, but I didn't have to. I could have just done the whole thing by typing things in. So I could be typing equal, don't forget the equal, PMT, and that tells me the rate. I would go 0.04 divided by 12 like this, comma, number period. I could go 30 times 12 like this, comma, present value, 250,000. Don't put in a comma in 250,000, right? I'm repeating myself, but it's important. And then I can either go comma 0, or just close out because those are optional values. I choose to just close out like this, and yep, same answer throughout. All right, that was the payment function in a loan situation. Now let me give you an example of a question that asks for the payment in an investment situation. Yasmin wants to save $100,000 to open a business in 10 years. She found an investment account that pays 5% a year. How much does she need to put in the plan each month to achieve her goal? So she puts in some payments that we don't know, a month. And in a math class, we assume that time started a month ago so that the payment can be considered to be at the end of the month. And there's some interest growing, and she makes another payment, and interest growing and payments. And her goal is that in 10 years, she'll have $100,000 in the bank. The interest rate is 5% or 0.05. Also per year, but the payment is monthly. What information do we have? We have the interest rate. We have this $100,000, which is something far in the future. So that's the future value. The time is 10 years, and the number of periods will be 10 times 12 because each period is 1 month. And the present value, the money in her account now, is 0. Let's do this payment calculation using Google Sheets and Excel. I started with Excel last time. This time I'll start with Google Sheets. Information that I put in, the future value will be 100,000. The time is 10 years. The interest rate is 0.05 a year, annual. And the present value is 0. It doesn't say that explicitly in the question, but since this is a new investment plan that she starts putting money in, we know it's 0. And we're looking for payments, PMT for payment. So again, in order to get Google Sheets and Excel to start calculating, we need to type the equal sign, PMT, parentheses. The first piece of information is the rate, which is this, divide by 12, comma, number of periods is 10 years, but that's years. We want periods, so you need to multiply by 12 times 12. Up here, see that? The star represents multiplication times 12, comma. Present value is 0, comma, and the future value is 100,000. And payment is assumed to be at the end of period, so I just close parentheses like that. I did enter and I had a negative answer of $643.99. It's negative again because money is being paid out, so it's a negative number. Let's now do the same thing all over again using Excel. Yasmin starts out with no money, so PV equals 0. She wants a future value of 100,000. The time is going to be 10 years, and the rate is 0.05 a year. We're calculating PMT, so equals PMT, parentheses. The first piece of information is the rate, so this divide by 12, comma. Number period is time times 12, comma. Present value, 0, comma. And then future value, 100,000. Type is optional and it's going to be 0 all the time. So I'm just going to skip it. I'm going to close my parentheses and hit enter. I get $643.99 in negative, just like the answer I got in Google Sheets. Let's take a look at this new problem. Ibrahim is putting $300 each month into an investment account that pays 6% a year. How much money will there be in the account after 4 years? Let's draw a diagram. There's an investment account that starts out with nothing, and Ibrahim pays in $300. There's some interest, and at the end of the month, Ibrahim puts in another $300. Interest, payment. So at the end of the 4 years, Ibrahim has a bunch of money in the account. The question is, how much is this? So this time period here is 4 years. What information do we have? We have that each payment is 300, but that's per month. That in our notation is payment, PMT. And the interest rate, R, is equal to 0.06 a year, which we will need to divide by 12 to get to per month. And we're asked for future value. Well, the future value is over there in the future. What is it in the present? Well, in the present, we're just starting out, so the present value is just 0. T is 4 years. We have all the information, and we can see that everything is there, right? The rate is there, the payment is there. How many payments? Yes, we know that too. The present value, yes, we know that. So now let's just calculate future value. We're going to use Excel and Google Sheets. Let's put in the information, PMT, rate, time, present value is 0, and we're looking for future value equals FV. And as soon as I open parentheses or click on the FV that appears down here, I have the information on what variables to put in. First variable is the rate, so it's this, divide by 12. Number of periods is 4 years, but because it's monthly, I need to multiply that by 12, comma. Payment is 300, but again, because it's paying out, I'm putting a minus 300, minus of the B1, comma, the present value is default to a 0. So I can either put in the 0 here or I just let it default. Close parentheses. And the answer is too big to fit. So I widen my column and I see that $16,000, $229.35. Now, why do I put in the information here and click them instead of just typing in? Because I could, right? Well, the thing is, if I lay out the information like this, then if the information changes, I can just change the number and I don't have to retype the formula. For example, here's one problem. If the next problem has the number 500 each month, then I just change this number to 500. I hit enter and the answer automatically changes. That's the advantage in laying out the information instead of typing it in. Another advantage is that if I make a mistake and instead of typing 4 years, I made a mistake of typing 44, then I can look back and say, oh, wait, it's not 44, it's 4. Whereas if I type it in and I look at it, I go equals FV, the rate is 0.06 divided by 12. The number of period is 4 times 12. The payment is negative 300. Present value is 0. But if I made a mistake and I type it as 44 and hit enter, I have this large number. If this is the only thing that's on my spreadsheet, none of this stuff is there. If this 775,000 is the only thing on my spreadsheet, I may not realize I made a mistake. And I'm looking at this, I may not see the repeated 4 right away. So yeah, lots of advantages to laying things out visible like this. Let's do this whole thing again using Google Sheets. Equals, I'm looking for future value FV. The rate is this divided by 12, comma, number of periods is this times 12, comma, the payment is negative 300, negative this number, and PV is 0. Same answer as before, 16,000. Let's take a look at this problem. A line of credit is a form of loan and it usually doesn't have a fixed term. Tanya takes out a loan of $25,000 from a line of credit with a 5% interest rate. She starts making monthly payment of $600. How much remains due on the loan after 3 years? So there's a loan of $25,000. So PV is $25,000. You get some interest, pays down, interest, pays down, interest, pays down. And if Latanya keeps on doing that, then eventually it will be 0. But the question doesn't ask about that. The question says after 3 years, so somewhere in between here, T is 3 years, there's some balance left, probably, maybe. I don't know, we'll calculate it, we'll find out. But there may be some balance left. And the question is how much of a balance? We have payment of $600 a month, and we have the interest rate of 0.05 a year. And the question asks for that balance right there, the balance that will be in the future. So that's the future value. So we have all of this information here. We're going to put it into Excel and Google Sheets. Put in the information. Present value is 25,000. The rate is 0.05. Payment is 600. And the time is 3 years. And we're looking for the value in the future, so equals FV. First information is the rate, this divide by 12. Number of period is this times 12. The amount of payment is 600, but because Latanya is paying out is negative 600, comma, and next is the present value. Present value is this number, and the type is default to 0, so I'll just close parentheses and I hit enter, and I get a negative 5784.80. That's negative means I still owe, Latanya still owes $5,784. It's a little tricky. It's a little tricky that this is positive and that's negative. Let's now do this on Google Sheets. Equals future value. The rate is this, divide by 12, comma. Number of periods is this, times 12, comma. The payment amount is negative of this, comma. The present value is this, close paren. 5784.80 still owed. All right, new problem. Jovita is an investigator doing a background check on Richard. She found that Richard has been making payments of $2,000 a month toward a 30-year home loan at a 2.5% interest rate. Compute the original principal of the loan. So Jovita found out that Richard has been making payments on some loan. So he took out some loan in the past, and now he's making $2,000 payments a month. And after each month, there's some interest. So it goes like this. We also know that it's a 30-year mortgage. So the question is, how much did the loan start with? If you imagine viewing it from the point of view of this point in time, then this is the present value. The future value is equal to 0, and the payment is 2,000. The interest rate is 2.5. Since we're looking for present value, our guess is that the function is going to be the PV function. We know that PMT is equal to 2,000. We know the time is 30 years. And we know the annual rate is 0.025. So we're looking for the present value equals PV. The rate is this, divide by 12. The number period is this times 12. And the payment is negative this number, 506,000. The original loan was 506,000. This can be done as Google Sheets as well. PMT equals we want the present value, so equals present value. Number of periods. Payment amount minus this 2,000. And everything else is default, 506,000. Let's finish with a fun question. Uriel wins the lottery and is getting $20,000 a month for the next 10 years. Assuming an interest rate of 4%, how much should Uriel get paid if he chooses to take a lump sum payment? Uriel is getting paid $20,000 a month for the next 10 years. But what if we want to bring it all back to today? For this kind of problem, it's easiest to think of it as the government owing Uriel money. We want to know how much Uriel should get paid if it were just a lump sum payment. That lump sum payment is unknown. So it's some sort of present value. But what do we do with all of these payments? Imagine you are the government. You have a choice of either paying a lump sum payment now or paying Uriel all of these payments. So what's equivalent is that instead of paying this present value, you tell Uriel, you know what? Let me owe you. I'll owe you this much money, and then I'll pay you all this money over the next 10 years. So this is equivalent to the government borrowing some unknown amount from Uriel and making all of these payments. All of these payments are like loan payments paid by the government or the lottery agency. This is just like a loan situation. So you can use the same spreadsheet as before, but except now you look at it, even though the question is asking about Uriel, you look at it from the point of view of the government. Then the government is making a $20,000 payment a month for a period of 10 years with an interest rate of 0.04. Present value of this lottery winning is $1.9 million. The actual total payments is going to be more than this, but because it's spread out over 10 years, right? For double checking, it should be more than this number. This much per month times 12 months in a year times 10 years equals 2.4 million. Yeah, more than this number. We get the same answer in Google Docs. There's a $20,000 payment over 10 years with an annual interest of 0.04. If there were no interest, it's 2.4 million. But now that there's interest, it's 1.975. All right, hope it's been fun. If you're not sure about when to put a negative or a positive something, double check on an example in the book where you know what the answer is so that you are sure of how the numbers should be put in, and then apply that to your homework. All right, hope that helps. Like, share, and subscribe for more contents. Thanks for watching. Bye.